All right, in this section, 4.3, we're really going to focus on what does the unit circle do for us. So yesterday, we went around the unit circle, and your paper is either yellow or green, and we labeled the coordinates for all of the points. Okay? We're going to talk about what those coordinates can do for us. So we're going to use the diagram in the next slide to answer the questions so that we can find special and important relationships in the unit circle. If you remember, a unit circle is a circle whose radius is 1. All right, so let's go over here. When we look here in the unit circle, right, if the radius is 1, this is the point 1, 0, this is the point 0, 1, etc. And in this circle, I have put a very generic point on that circle. I've called it point P, and we don't know its coordinates. We're just going to leave it as a very generic X and Y. So it says, what is the length of the hypotenuse? Well, this is the hypotenuse, which extends from the center all the way out to the edge. The hypotenuse has a length of 1. It's the unit circle. The radius is 1. All right, so it says label all 3 sides. Well, I've already done 1. Use the side lengths to find these 2 trig ratios. All right, so to get up to this point, x comma y, the coordinates tell us to go over x and to go up y. Right? If that was the point 2, 3, we'd go over 2 and up 3. So the coordinates tell us the 2 sides of this triangle. All right, so now let's go in. Here's theta. Theta is between our terminal side and our initial side of the angle, and they want us to find the sine of theta. Sine is the opposite side over the hypotenuse. So y divided by 1, which is just y. Let's put that in a big box. Cosine is the adjacent over the hypotenuse. The adjacent is x, the hypotenuse is 1, x divided by 1 is just x. This is a really, really, really big connection because we're saying when we're in the unit circle, the sine of any angle is the same as its y coordinate. The cosine of any angle is equal to its x coordinate, if you know the point. Okay? All right, so let's see how this works. It says let's use these facts along with the unit circle from yesterday, so make sure you have yours out, to find the exact value of these 4 trig functions. So they want us to find the sine of 5 pi over 4. Sine is the y coordinate of this angle. So let's grab our unit circle. I'm going to back my camera up a little bit. And let's go find 5 pi over 4. 5 pi over 4 is down here in my 3rd quadrant. Here are the coordinates. If they're asking for the sine, they're asking for the y coordinate, which is negative radical 2 over 2. Okay. Here they want the cosine of 300 degrees. So we want to go to our unit circle. Let's go find 300 degrees. And they want the cosine. Cosine is the x coordinate, which is positive 1/2. Now, if you haven't gone around your entire unit circle, we started to in our last lesson, if you haven't gone around and finished putting your degree angles in, I highly recommend you do that. Okay. Well, I guess the blank copy, or the final copy I gave you has that in there. No, it didn't. I don't know. If it's not in there, let's go do it. All right, they want the cosine of pi. Again, cosine is the x coordinate, so I'm going to go find pi, which is here. And the x coordinate is -1. And then they want the sine of -13 pi over 3. Okay, well, what we need to remember is that's going to be outside of our circle. Let me back this up even more. All right, so pi over 3 are my green angles. So I'm going to count backwards 13 of them. 1, 2, 3, 4, 5, 6, multiples of 3, 7, 8, 9, 10, 11, 12, 13. So that's the same as 5 pi over 3. What did they want? I think, was it sine? Yes, they want the sine there, and sine is the y coordinate, which is negative radical 3 over 2. Okay. All right. So before we move on, let's just talk about checking these, or some of them, on a graphing calculator. So one thing to notice is that these three angles were in radians, and this angle was in degrees. And that's important to note, because if you're going to check this on a calculator, you need to tell your calculator what mode you're in. So the first thing I'm going to do is hit my mode button. And right now my calculator is in radians. Great. All right, so let's get out of there. Let's type in this first one. I want the sine. Sine is, our trig functions are right here above the 7, 8, and 9. So I want the sine, and I want a fraction, and I want 5 pi over 4. Sorry. Okay. And it spits out a decimal. We have the exact value, meaning not a decimal. So let's just do a quick check here. Negative radical 2 divided by 2. Perfect. All right, let's do this one here, the cosine of pi. So I hit cosine, get my pi in there, and it spits out, perfect, negative 1. Now if I want to check this one, if I type in the cosine of 300, this is not 1/2. But my calculator is in radians, and it's thinking I'm asking about 300 radians. So first thing I need to do is go to mode, and I need to go change it to degrees. So I hit enter so that now degrees is highlighted. And now when I ask it to do the cosine of 300, it knows the answer is 1/2. Oh, excuse me. All right. Whew, sorry. So it says we observed how sine and cosine are related to the unit circle, but what about tangent? So using our diagram above, let's find the ratio for tangent. Remember, in SOHCAHTOA, tangent is the opposite over the adjacent. So let's go back up here. Here's theta. The opposite is y. The adjacent is x. So the tangent is the y coordinate divided by the x coordinate. Okay. Well, it says make substitutions to write another expression for tangent. So I'm going to slide back up. Do you remember how y was the sine of theta and x was the cosine of theta? So instead of saying y divided by x, we could say that y equals the sine of theta and x equals the cosine of theta. So that's another relationship. Tangent is the same as sine over cosine. Okay. All right, so they'd like us to do two more. Find the exact value of the tangent of 11 pi over 6. So tangent says we need the y coordinate divided by the x coordinate, and we're going to go find 11 pi over 6. So 11 pi over 6 is here in the fourth quadrant, and its coordinates are radical 3 over 2, negative 1/2. So I do y divided by x, and I'm going to do it down here. So I have negative 1/2 divided by radical 3 over 2. I am dividing fractions, so let's flip and multiply. Cancel some 2's, and I'm left with negative 1 over radical 3. And if I rationalize this, and I believe we did this in our homework 3 times, if I rationalize this, I get negative radical 3 over 3. Okay. Good. Let's do the next one. The tangent of negative 45 degrees. So 45 degrees is pi over 4. Negative pi over 4 puts me here at 315, or 7 pi over 4. So here are my coordinates. I want the y divided by the x. So I have negative radical 2 over 2 divided by positive radical 2 over 2. And a negative divided by a positive is a negative, and anything divided by itself is 1. So I get negative 1. And again, that's absolutely something I can check on my calculator by hitting tangent of negative 45, because I remember I'm already in degrees. Okay. Good. All right, let's flip it over. So, here in our math notes box, it's just what we've already done. I just put it in one spot. For an angle theta in standard position means the initial side is on the positive x-axis and the terminal side is, well, anywhere in quadrants 1 through 4. The following definitions exist. So when you're in the unit circle, radius of 1, sine is the y-coordinate, cosine is the x-coordinate, tangent is y over x. Okay? All right. So let's wrap up with this here. It says, using your unit circle that we've been using and the relationships we found today, let's answer the following. It says, what is the sine of every pi over 6 angle? So remember, sine is the y-coordinate. Well, let's go look at our unit circle. I'm going to back it up a little bit so we can see more. All right, so my pi over 6 angles are my blue angles, right? You see my blue lines, 5 pi over 6, pi over 6, 11 pi over 6, 7 pi over 6. It wants the sine or the y-coordinate. 1/2, 1/2, negative 1/2, negative 1/2. So all pi over 6 angles have a y-coordinate of either positive or negative 1/2. Right, so when we're in the form sine of a number, pi over 6, so 5 pi over 6, 7 pi over 6, 11 pi over 6, the sine will always be 1/2. Same thing with the cosine of every pi over 6 angle. Cosine is the x-coordinate, so let's go back to our picture here. Go back to my blue angles. Cosine is the x, so the x-coordinate's radical 3 over 2, negative radical 3 over 2. All 4 of them have the same x-coordinate, which is either positive or negative, radical 3 over 2. Well, I don't need to go back to my picture to answer this last question. It says, what is the tangent of every pi over 6 angle? If sine is the y-coordinate, cosine is the x-coordinate, and tangent is y divided by x, well, first of all, we know it's either going to be positive or negative. And we're doing y divided by x. So I have 1/2 divided by radical 3 over 2. We already did this, didn't we? We already did 1/2 divided by, I know you can't see it, radical 3 over 2. And we got radical 3 over 3. Right, if we've already done it, we don't need to do it again. Okay. And so these are connections that we will start putting together so that we can very quickly stop feeling like we need to draw the entire circle and label all of the coordinates. We're going to start noticing, well, we should have noticed already, there's really just 5 numbers on this chart. A 1, a 0, a 1/2, a radical 3 over 2, and a radical 2 over 2. So instead of writing, tens of numbers, we just have 5. Okay? And these are the connections that we're going to continue to make.